Good morning, 8th grade. Ladies and gentlemen, we are about to begin our STEM project for this week in modified fashion. Speaking of fashion, you'll notice, Robbie, I am wearing my Tuesday attire, and check out my tie. It is Tuesday. Anyway, back to our STEM project here. As you know, we were going to be creating a homemade battery throughout the week this week and competing against one another in teams as to who could create the strongest battery. Well, that's not going to happen this week, but we're gonna change things up and we're gonna try and do something at home that will be just as interesting. So before we get started, I have to mention a few things here. I know that not everybody has certain equipment at home. Like, unless you're Dan, you probably don't have a multimeter like this laying around in your garage or in your kitchen. And you may or may not have a battery tester like this. And you may not even have wire laying around. So, how in the world are we going to be doing a project that involves the use of electricity and creating batteries? Well, let me explain it to you. I am thinking that most of you probably have certain materials at home that I'm going to make some suggestions here as to how we can actually make a homemade device to test batteries. And we'll go from there. So I'll find out from you when you respond to the assignment today how successful you may be throughout the day. So let's start with the simple part. I'm thinking most of you probably have a refrigerator at home. And on that refrigerator, I'm thinking many of you might have a refrigerator magnet of some kind. I know there are millions of different kinds of fridge magnets, but I'm thinking probably most of you have a refrigerator magnet laying around at home. And if you don't have a refrigerator magnet, I'm thinking you probably could find a magnet in something. So if you have a magnet, we're off to a good start. If not, you let me know when you comment to me later and we'll work out some other details. Now, with this magnet, you are going to be creating something using another simple device, which is in the form of a paper clip. I'm thinking most of you probably have a paper clip laying around at home. So I'd like you to try to locate a paper clip. And once you have your paper clip, I'd like you to open it up, stretch it out, and make it as straight as possible. This is going to be really important because I'm going to talk you through the steps on how we can use really simple materials to make a device, a homemade device called a galvanometer. You can look this up online as well. But a galvanometer is an instrument that can be used to measure electrical current. So this is our first part of our STEM project this week at home, is to make a homemade galvanometer using some really simple materials. Again, starting with a paper clip that you will stretch out and make it as straight as possible, and a fridge magnet. So again, if you have these two things, you're off to a great start. If you've got a Sharpie as well, if you take that straightened paper clip and just color in one side of your paper clip so that you can tell the difference between one side and the other, that would be awesome. And then take the magnet and you're going to magnetize your paper clip. Now, if you don't have a paper clip, maybe you have a sewing needle at home. That would work as well. Just something small, straight, and metallic is what you would need for this. Now, to magnetize it, all you have to do is be patient. You're going to take the magnet, no matter where you found it, and you're going to stroke the paper clip over and over and over again. In fact, I'd encourage you to count while doing this and get up to at least 100. Now watch what I do when I stroke it. You're putting the magnet on the upper end where you're holding it down to the lower end that you marked. And you're going to keep on stroking it over and over again. And essentially what you're doing is aligning the electrons to flow in one direction. You're creating a magnet out of that piece of metal. If you think back earlier in the year, we talked about the different types of atomic bonds, the covalent bonds, the ionic bonds, and the metallic bonds. And so right now we're taking advantage of the metallic bonds and the arrangement of those valence electrons, and we are arranging them all in one direction so that they are all in alignment with one another. Now, as we do this over and over again, as I said, do it at least 100 times, even more if you have the patience, and this could be very therapeutic and relaxing. So, Nick, I want to hear from you as to how relaxing this is after you've done it 100 times or more, okay? But once you've done that many times, you're then going to take this paper clip that you've magnetized and turn it into a compass. A compass from a piece of metal? Oh, yes. This is how you're going to do it. You're going to take a little bowl. Doesn't matter what kind of a bowl, but just something that you can put a little bit of water into. And I would imagine most of you probably have either water bottles or 2-liter bottles or something with a cap on the top. Now, if you don't have bottles with a cap on the top, don't panic. It's okay. See if you can find something else that floats on the surface of the water. Because what you're going to do is you're going to put a little bit of water into your bowl. Don't overflow it, but put a little water into your bowl. Put the cap into the bowl so that it's floating on the water and it's free to move. Then you're going to place that magnetized piece of metal into that cap so that it is floating in the center. Oh yeah, in the center of your bowl. Now I'm watching this right now, and I've created a compass. And this compass is always pointing north. So no matter how I move this bowl, no matter how I might spin this cap with the piece of metal on it, I am noticing that it's spinning around until that point that I colored in is always pointing in the direction of north. So there we have created a compass. So if you've gotten to this point, we are halfway there to creating your galvanometer. Now for the next part. This might be a little bit more challenging. Let me put our compass off to the side here for a moment. As I mentioned before, not everybody might have a roll of wire laying around. If you live near someone like Dan, maybe give him a call and say, hey Dan, can you throw some wire our way? But if not, I would imagine most of you probably have something else laying around, maybe that you just haven't gotten ready to throw out yet. Maybe an old USB charging cable or some other type of device that has a wire in it. Now, just today, I found an old charging wire that I don't use anymore. It doesn't even fit my devices anymore. So I asked my wife permission if I could destroy it. And you take a pair of scissors and you just snip the ends off. So make sure you ask permission before you do anything of the sort. But if you snip the ends off of a USB charging cable or another similar device, and you peel the rubber casing away, you will notice that there's some wire inside. And this wire is perfect for creating your galvanometer. Now for this charging cable, there were actually 4 wires inside, a white and a green, a black and a red. Color really doesn't matter for this activity. They're all the same kind of wire. Now, what are you going to do with these wires once you find them? I took 2 wires. I chose to use the black and the red wire, and we'll be discovering throughout the fourth marking period that red and black are universal colors in electronics. Black is negative and red is positive, and we'll be getting back to that point later this marking period. But if you have the red and the black, that would be great. And very simply, you can take a pair of scissors and carefully take the ends of your wires with your scissors, with your thumb like this, and just peel away the end of the casing, the rubber casing, that colored part of the wire. Just pull it right off so that you have exposed wire at the end. Now, as I said, I took the red and the black wire and I spliced them together. I took the two ends of the black and the red and wrapped them together to make one long wire, and then I looped it. I looped it like this to make 4 loops of wires. Now, why did I do that? Well, because it fits perfectly around my compass, my homemade compass, with my needle, my magnetic needle, and the cap floating in the water. So here I have 4 wires around my compass. Now here's a good activity for you to do. Get a battery. AA battery is fine. All of you that responded to yesterday's assignment, most of you said you've got AA batteries laying around. So if you got a AA battery, try something very interesting. Take that AA battery and connect one end of it just with your finger. You're not going to get electrocuted or anything like that. Hold the black end to the negative side. Take the red side to the positive side of the battery. And when you do that, notice what happens to the compass needle as it is floating on the cap. Remove the wire, attach it again. Now, I'm not going to tell you what is happening here because I want to hear from you in the comments as to whether you were able to successfully make this device, this galvanometer, with some homemade equipment that you probably have laying around. I'm hoping that most of you have some of this laying around. And use your imagination, use your creativity. Maybe you can find some other materials that can duplicate the things that I just discussed here today. So your assignment today is to try to create a homemade galvanometer which will take the place of a multimeter device in order for us to start our experiment making a battery tomorrow. So let me hear from you after you've given this a try. Tell me your trials, your concerns, your questions, and we'll work through it together. You have a great day, stay safe, and I'll see you tomorrow.